Often when discussing motorhome solar installations with clients, there is a lot of confusion around panel voltage, especially if the vehicle the solar is being fitted to has a 24 volt starting battery but 12 volt house batteries. This video will explain why battery voltage no longer has any bearing on the type of panel that you should be installing. But if you don't want to watch the entire video, here's the short version. 1. Make sure the solar controller you own is MPPT. 2. Check the datasheet of your controller and take note of the maximum open circuit voltage and maximum current listed. On this example, our controller here for the Victron 7510 has a maximum open circuit voltage of 75 volts and a short circuit current of 13 amps. Now check your solar panel. If the maximum open circuit voltage and short circuit current is less than the open circuit voltage and short circuit current of the controller, then you're golden. Go ahead and connect your solar panel up. If you're installing a PV array, or wish to understand why we have the so-called 12 or 24 volt panels, then keep watching. Let's have a look at this Victron 90 watt 12 volt solar panel. The specifications for this panel indicate a maximum power voltage of 19.6 volts and an open circuit voltage of just over 24 volts. This feels like a 24 volt panel, and yet it's rated 12 volts. So what exactly is going on? The 12 and 24 volt panel ratings are a throwback to previous times. In the early days, when the controllers we use today were not around, the solar panel was connected more or less directly to the battery, and the only method of solar control was the number of cells installed in the panel. Manufacturers created the best compromise they could and sold panels as 12, 24, 48 volts, etc. That is why a solar panel that has an open circuit voltage of 20 to 24 volts is still considered a quote 12 volt panel. This method is incredibly inefficient, as the battery will pull the panel voltage down. Have a look at how connecting this battery changes the output voltage of the panel. Panels have a specific voltage that they are most efficient at, usually around 17 to 20 volts. So having a panel trying to charge at voltages below this is undesirable. Additionally, there is no possibility of adjusting the charging algorithm for different battery chemistries such as gel, AGM, lead carbon, etc. Once electronics became more common, we saw the advent of pulse width modulated controllers. This was an early attempt to increase panel efficiency and allow different charging algorithms. Pulse width modulation is basically a switch that connects and disconnects the panel from the battery bank about 50 times every second. Increase the time the switch is on and you raise the charging voltage. Decrease the time the switch is on and you lower it. This allowed the controller to set the charging voltage depending on the type of battery installed. A quick note on pulse width modulated controllers. This outdated technology is still being sold today at pretty high prices, and often it's difficult to tell what type of controller you're purchasing. If you're unsure, either buy from us or download the datasheet for the controller and make sure that it says MPPT. MPPT stands for Maximum Power Point Tracking and has achieved a massive leap in efficiency of solar charging. The beauty of MPPT is that the controller completely isolates the PV circuit from the battery circuit. It constantly adjusts the voltage and the current from the panel to get the most power possible while using the best charging algorithm for whatever battery is connected. If we take a look at this Victron 115, we can see that it has a maximum open circuit voltage of 100 volts. This allows us to fit both these 24 volt panels in series, producing over 80 volts yet charging a 12 volt battery. That is why the old 12 or 24 volt panel ratings are now completely redundant. Just check the datasheet of the controller, and if the rated open circuit voltage is higher than that of the PV array, then you're good to go. A quick word of caution: any system voltage over 50 volts is considered dangerous. In the systems we design, we restrict voltage to 50 volts or less for safety reasons. If you need any help with this, put a question down in the comments and I'll make a video to answer it. or if there is enough interest, then I'll put together a free webinar to answer questions and give advice. Otherwise, if you'd prefer to just leave it up to the professionals and you live in New Zealand, then get in touch and we can do it all for you.